Alright, we're at gotomath.com working some calculus. We're evaluating limits numerically, and we are in this section right here, and that's the actual one I need to come up. So we have the limit as x approaches 7 of x squared minus 49 over x minus 7. So let's move over to the whiteboard. Alright, we have the limit as x approaches 7 of x squared minus 49 over x minus 7. We're doing this numerically in this particular section here. Just getting an idea of what this limit thing's all about. And trying to write neater. It's tough doing. Alright, we got the limit. Of course, my handwriting's great on a regular pencil and piece of paper, but writing on this bamboo tablet's not exactly easy. Okay, we could write it like this. The limit of f of x approaches 7, and then define our f of x over here if we wanted to. So just to let you know. Now, I'm going to factor this. This is a difference of two squares here. And this is going to really become important when we go to evaluate these limits analytically to get a precise value on them. We got a term in the top and a term in the bottom that can actually cancel out. I can actually rewrite this limit. F of x is equal to x plus 7. But the thing of it is I have to state, in order for both these to be the same function, which they don't look the same, is I have to state that their domain, or their domain must be the same. And that means that we're going to have to throw 7 out of the domain of this function here. Okay, we can't use 7. We can't use 7 here because you get 0 over 0, right? You get 0 in the denominator, and that's not good. So we have to throw it out here. Now, what I'm going to do now is we're just going to kind of sketch a graph of this thing, get an idea of what it looks like. So we have slope 1 past the 7, so we'll just say that's about right here. And of course these graphs are never to scale. Man, I tell you what, that's pretty darn straight. Okay, so the point of interest on the x-axis is obviously at 7. This is where it's undefined right here, okay? We can't plug 7 into this guy here. Alright, can't do it. And so we don't know where this hole is actually missing. We don't know. We don't know. But what we could do is we could do this what's called numerically, and that is plug numbers into the left of 7 and get really close to 7 coming in from the left and take a look at those values. And what I mean by that is you could do this. So let's do 6.9, let's say. That's close to 7. So we're taking 6.9 and we're plugging it in, right? Or I should say over here. And right, so 6.9 minus 7. Of course, I'll let you get the calculator out and take a look at whatever that number is. And then we want to do, let's say 6.99. Right, 6.99 squared minus 49 over 6.9 minus 7. And then take a look at that. Now that's coming in from the left hand side, and as we get closer and closer, boy, that's, let's say that right there, L is where the hole's at, and we'll say this guy right here was one of the numbers right here. So as you can see, we get closer and closer to 7. What's happening to my y value here? It's getting closer and closer to y, getting closer and closer to L, right? And then if we come in from the right hand side, f of 7.1, so we have 7.1 squared minus 49 over 7.1 minus 7. Okay, we get that number out, and we continue to do that. And then what we'll want to do is we'll want to compare, right? Coming in from the left, what does it look like it's approaching? And then coming in from the right hand side, what does it look like it's approaching? And if they're both approaching the same number, well, then this limit is probably going to be equal to that number. All right. Now, let's move back to the web page here real quick. Let's hit help. And of course, you can see that's the way we've got this worked out here. We came in from the left hand side, so this would be like 6.9, right? And we got 13.9, 13.99, and as you can see, this thing is moving towards 14, it looks to me like. And then we come in from the right hand side, right? So this would be 7.1 when we added these together, and then so forth. And as you can see, this is definitely getting closer to 14 also. So both these numbers are converging towards the same number, and that means that the limit exists and it's equal to that number. Let's hit the answer here and see exactly what that is. So it's 14, as you can see, clearly see. We can clearly see this right here. So that's all you have to do when we go to evaluate these limits. However, there will be some other techniques that we'll use in the next section. All right. Okay. Moving on to the next. Moving on to the next problem. So come and visit. GoToMath.com. Thanks. Bye.